I'm talking to you today about a tool called FogNet that we developed to support our consultancy activities, mainly in the defence market. So imagine that you're part of a large organisation and you want to roll out some communications and information infrastructure, a large-scale enterprise-wide infrastructure. And you would like to know whether it supports a range of services. So, for example, you may want it to support some collaborative tools, some machine-to-machine communications, all the standard tools you might see in an enterprise. Now, before you roll it out, you would like to have some idea of whether this system is fit for purpose intended. So, what's usually written as or described as a cloud is actually a complicated collection of communications information infrastructure, equipment, switches, routers, etc., each of which is quite a complex bit of kit. So early in the process, it would be very useful to be able to have some kind of model of that infrastructure that the users and the systems can utilise as if they were using the real system. If you catch problems very early in the project, it can have large consequences, benefits. So it's important to realise as part of that process, what's very useful is to have the people and the systems actually using some kind of executable model of such a system. So really what we're saying is the system fit for the purpose intended? We would like to do that analysis reasonably early in the project. That has large benefits. We would like to have a lot of confidence in the results, and so we would like to have a high fidelity model. And a lot of this really is about what is the user experience across such a network. Is design A going to lead to an experience for the users that they see as adequate? Do they have certain delays in their service that is unacceptable? Is the capacity or other unintended consequences of that design going to lead to some problems? So there are many ways you might want to tackle that problem. The first thing you might want to do, for example, is some kind of a theoretical analysis. For most situations, that's an intractable problem. It doesn't really capture the complexity of such a system, and at the end of the day, you can't easily plug people and systems into such a model and get them to experience some kind of usage of that system. So then what you normally do is you would go with some kind of a computer simulation. This can have a long development time. It usually doesn't capture the kind of complexity you look for, and if you try and build it for that sort of complexity, it doesn't run fast enough in real time such that people and systems can use that as a way of experiencing that network. The simple solution is to build it and see if it works, but clearly that's if you're doing I want either a design A or a design B, that's infeasible. It can't scale and it's very expensive. So the observation, though, is that a lot of the complexity in the equipment that makes up this information and communications infrastructure is the software itself that sits inside this equipment. So if you can take the software out of the equipment and run it with some scenarios, you have a very flexible and powerful tool that, for all intents and purposes, acts as if it was the real infrastructure. So this is what FogNet is. We've taken the real software from equipment, we've taken scenarios to do some rapid what-if analyses on this system, and what we've worked very hard to do, and this is the difficult bit, is to make that whole thing run in real time so that systems and people can experience what would really happen if the thing was built. So, we've taken the infrastructure, we have some controlling PC platform, we have the software version of those bits of kit from the infrastructure, and if a user, for example, wants to communicate with some system, let's say it's a server or a database somewhere else in the infrastructure, they communicate through the software representation of that bit of kit. As far as they're concerned, it behaves exactly the same way. As far as the server, for example, down the bottom right, the request has come through that infrastructure exactly like it would happen in the real system. So what you have is a very powerful, flexible way of rapidly seeing whether a system is fit for the purpose intended. So we've actually done this in the defence sector in a medium-sized defence project called JP 2096. And what we did there was we were asked by Defence to evaluate a system that was going to be used on top of the existing information infrastructure, the defence information environment. They wanted to know whether that system would work across the defence information environment, but then for various portions of that defence information environment, some of which are overseas, some of which are in Australia, some of which are cable, wireless, satellite. So what we did was we created a suite of different options and saw whether that service was adequate over that infrastructure. And most of the time it was. We then went on to adjust capacities and the type of equipment you might see in that infrastructure until we broke the service, and then we fed that information back to Defence, and then they thought again about how they might use that service over the infrastructure. FogNet at the moment it's a tool that we use to do our consultancy services. It is not a product as such, although it may become one. Currently, we're working on some improvements to the ease of use. It's adequate already to do most of the consultancy that we are bidding for. We are working on some improvements to the ease of use, and in particular, some of the items of functionality we see as being important in the defence projects we're currently bidding for, where we see FogNet as being an important part. The IP position is that the University of Adelaide owns the IP, but we're in a joint partnership with an organisation called DCIC. DCIC retains the rights to use FogNet in the defence market. There are clearly a number of patents that could be that are crucial parts of FogNet that could be used. At the moment, we're relying on trade secrets. Now, this is I don't expect you to read everything on the diagram, but this is a view of the defence project landscape, and in particular, these are large defence projects. The opportunity for FogNet is for it to be a crucial part of evaluating, for example, tenders in a range of large defence projects, and these are multi-billion-dollar projects, some of which we are working with at the moment. In the non-defence sector, an example might be we would see FogNet as being potentially important to looking at planning the part of the NBN that's not covered by the fixed infrastructure. So the last 6% of the NBN, helping to plan and design that infrastructure, we see FogNet as being quite important. We're currently validating the business model as we work through. FogNet was developed recently. We're working through some things at the moment. Really, we're validating that model with some clients. I see potentially in a couple of years' time we might look at maybe licensing FogNet to some larger defence primes. That's kind of the end of my presentation. Just a few notes to say that in particular I think what would be useful for us is any feedback on the kinds of timescales I've suggested. So for example, 2 years in order to license from where we are now to where we want to get to. Whether you have some thoughts on levels of funding or sources of funding that might help us get there. And in particular, I think we understand the defence landscape quite well. If you had some thoughts on the use in the non-defence market, I'd be very interested to talk as well. And any discussion on IP protection, I'd be interested in talking about as well. Thank you.